So continuing on lesson 6.1, we still basically have the same learning goal. This is hopefully what you learned yesterday, how to simplify and evaluate an expression that contains zero and integer exponents. Okay, well, I did take the time on the notes yesterday to do this, and I'm doing it today because I really can't let you out of 9th grade until you can tell me what an integer is. So you got this, Colin? What was the question? What's an integer? Well, that's good. You got that part for me. Okay. What is an integer? What does it mean, an integer exponent? Benton?
A number value that is either negative or positive, but has to be a whole number.
Okay. So it's either negative, can be either negative or positive, but has to be a whole number. So we do not call the negatives whole numbers. So basically, the kind of like technical definition is the whole number set, which starts at 0, the whole number set, 0, 1, 2, 3, that pattern continuing on forever, and their opposites. That's how the negatives get included. Because we know that the opposite of 5 is negative 5. So negative 5 is an integer just as well as 5 is an integer. So really what ends up happening is you guys have worked with integer exponents before, but only the natural numbers, the counting numbers probably. Something to the first power, something to the second power, and so on. So now we're including in there, yesterday you learned what happens when you take something to the 0 power, what happens when you take something to the negative power. So just a little reminder, let's remind ourselves in these notes, an expression is not considered simplified if it has 0, if there are any bases being taken to the 0 power, that is not a simplified expression, or negative exponents. If something still has a negative power, it has a negative exponent, it is not simplified. So we cannot consider it simplified until we get rid of all exponents we can get rid of, and there is absolutely no 0 or negative ones left. Let's kind of do a quick review here. Anything to the 0 power other than 0 itself, anything except 0 itself to the 0 power is what? 1. Did you try that on your calculator to see if it actually works? Go ahead, pick a base. Put it in your calculator. Pick a base. If you're going to pick a negative number, which you can, by the way. Oh, now you don't have your calculators because I said we're probably not going to use them. I said you bring a calculator every day. If you're going to pick a negative number, because if I were you, I'd be kind of curious if a negative number would work also. Put that in parentheses before you take it to the 0 power. If you're going to take a positive number to a 0 power, probably don't have to worry about the parentheses. But 0 to the 0 power, we're not even going to bother with because we're saying it cannot be 0, our base. So Avery took a negative, oh my goodness, this dude took, let's see. I gotta find where the commas would go here. He took a negative 55,488,688 to the 0 power. And he got 1. I should have made you read that number. Yeah. Just kept keying in some numbers until you got something. And anybody else? Did anybody else take something to the 0 power and get 1? Because can we trust our calculators? Yeah, if we know how to put things in properly, we can. Can anybody verify that no matter what number we take other than 0, in other words, you tried 1 and you got 1. How about you, Easton? Did you? 5 to the 0 power, and it was 1. Okay. Anybody else? Really? Okay, I know what the problem is. You don't know how to use the power key in your calculators. Maybe that's it. So this key, is there an upside down B key in your calculator? That would be raising something to a power. Is there a Y to the X key? Y raised to the X power? Well, that key might do it for you. So you might want to know how to do that. Okay, well, I'm just going to go with then that, I trust that anything to the 0 power is 1. Could you try 0 to the 0 power, those of you who are willing to cooperate here? 0 to the 0 power, what do you get? Domain error. Because Anybody think they know why we can't? What do you suppose 0 to the first power is? Won't let you do that. 0 raised to the first power. 0. Wonder what 0 to the second power is. 0. Okay, but do you remember yesterday off to the side I did that 2 to the third, 2 to the second, 2 to the first, 2 to the 0. Did I do that? No. Yeah, on the left side of the margin. 2 to the negative 1, 2 to the negative 2. And I said, okay, 2 to the third power is what? 8. 2 times 2 times 2 is 8. And then to get 2 to the second power, what's that? 2 to the second power is 4. And 8 divided by 2 is actually 4, isn't it? And 2 to the first power is 2. And 4 divided by 2 is 2. And then 2 to the first, 2 to the 0 power, well, we don't really, at this point, we probably didn't know what that was, so the best we could do is say, well, I had 2 for 2 to the first power, so again, I would divide by 2, and I would get 1. So now, what happens when you do 0? So 0 to the second power is 0. Can you divide by 0 to keep going down in powers? Can we divide by 0? No. That's why your calculator goes into domain error. We cannot divide by 0. So, we have to remember that that anything except 0 to the 0 power is 1. Okay, what's the rule I said then for negative exponents? Something being taken to the negative power does not make it negative. No, never. If you're taking a positive number, I guess maybe I should have made sure that I said that. If you're taking a positive number to a negative power, it will not make that number negative. It's not like you're multiplying by a negative. That's not what's going on. What will it do instead? Yeah, we end up with those fractions if our base is greater than 1. Okay, so now we're going to do a little bit more abstractly. We're going to do it with variables, and this can get confusing for students. So stay with me. No tuning out. It is not the weekend yet. 2 r to the 0 power m to the negative 3 power needs to be simplified because it has a 0 exponent in it, it has a negative exponent in it, so we have to simplify it. So we're going to take the parts because in reality what we have here is 2 times r to the 0 power times m to the negative 3 power. That's multiplication. Well, does 2 need to be simplified? No, 2 is not being taken to a 0 power or to a, but we are going to make it into a fraction. We're going to put it over 1. Because I'm calculating there might be a fraction involved in this problem. R to the 0 power, we're always going to assume, you get to assume here, that the variable does not equal 0. So r to the 0 power, what are we going to simplify that to? 1. Anything to the 0 power is 1. And we can make 1 into a fraction also by putting it over 1. Anything can be made into a fraction by putting it over 1. M to the negative 3 power, does that need to be simplified? Yes, it's being taken to a negative power. How can I rename that or simplify that?
1 over m times 3.
Not m times 3. M to the third power. Thanks for helping out over there. 1 over m to the third power gets rid of our negative power for us. Okay, now we have a fraction times a fraction times a fraction. Let's multiply across the top. What do we get?
2.
2. And downstairs,
3.
m to m to the third power. That is not m3. I'm going to have to make that a little bit more legible here. Okay. Is it simplified? Can we do anything else?
No, we cannot.
Are there any 0 powers left?
Negative.
Any negative powers left?
No.
Okay. 2 over m to the third power can't be simplified anymore. We're going to say there's our final 3 results. We are done with that one. Okay. How about this next one? R to the negative 3 over 7. Any ideas what we can do here, Benton?
Would we want to rewrite it as r to the negative 3rd power divided by 7?
That would be a great way to start this one. r to the negative 3 power divided by 7. And then remember, we can change division to multiply by the reciprocal. So we're going to change this to, you know what, instead I want it to be r to the negative 3 times the reciprocal of that 7. Can we just put a 1 underneath r to the negative 3 now and just multiply?
Yep.
What's it going to do if we did that? Take us back right where we started. Can we have a negative power in our... No. So what are we going to do? We're going to now rename r to the negative 3 power as what? 1 over r to, you've got it down how to say that now. 1 over r to the 3rd power times r 1/7, which does not need to be simplified. And now we would multiply across 1 times 1, 1 times 1, 1, and r to the 3rd times 7. Here's what algebra likes. Algebra likes the constants in front and the variables behind them. So how are we going to write this? 7r to the 3rd power. Okay, so the constant in front, the variable part behind it. 1 over 7r to the 3rd power. Okay. What do you think we could do with the next one? G to the 4th divided by h to the negative 6. Could we just write it that way? Get rid of the fraction bar and use the division like we did in the last one?
Yes.
Okay, let's try that. So we're going to do g to the 4th divided by h to the negative 6. Well, let's just go right to changing that to a multiply by the reciprocal problem. So we have g to the 4th times, oh, you know what? No, I got a better idea because I think it's going to be confusing if you try that. I don't think you're going to understand it as well as you should. So go ahead and just erase that. Oh yeah, maybe you were working ahead. Let's simplify this before we change it to a multiply by the reciprocal problem, okay? So we're going to make this g, I need a pen back, g to the 4th times the reciprocal of h to the negative 6 power. So it's going to look like that, 1 over h to the negative 6 power. Oh, I just did the same thing. Golly. Will you just stay with me? It's Friday. That's what happens when I take a day off, I guess. Okay. We're going to leave it as divided by. We're going to leave it as divided by. Let's keep going back to the way that I think is going to be more confusing for you. But you're already confused now, right? Yeah. So, okay, stick with me. We're going to leave it divided by, and we're going to simplify h to the negative 6 power. How can I simplify h to the negative 6 power? 1 over h to the 6th So now we've gotten rid of the negative power. Now, though, we have to be able to perform the operation. So to perform the operation, we say, you know what, now I'm going to change it to a multiply by the reciprocal problem, which becomes h to the 6th over 1. It flips over, it becomes its reciprocal. We'll make g to the 4th into a fraction by putting it over 1 also. And what do we have? G to the 4th times h to the 6th.
G to the 4th, h to the 6th.
You know, they aren't the same base, so we can't do anything like combine them somehow. So, does G come before H in the alphabet? Because that's another thing algebra likes alphabetical order. E, F, G, H, yeah, it does. G to the 4th, H to the 6th. And downstairs we have 1 times 1. That's 1. Do we need it? No, we don't need it. Here's our answer. Sit up, Colin. You're making me tired. I got a long day ahead of me, I think. Okay. Anybody have any questions about any parts of those three that you want to go back and have clarification on? Okay, then let's go try a few more here. More practice because this, we need more, trust me. When it's time to start the homework, you might get a little bit irritated with this. Okay, let's make this into multiply, multiply. So remember, now we go along and we say, is there any simplifying I need to do? So does 3/4 need to be simplified?
No.
No. So we'll leave it 3/4. Does x to the -2 power need to be simplified?
Yes.
Yes, it's to a negative power, so 1 over x squared. Does y to the 3rd power need to be simplified?
No.
Why not?
It's not a.
It's not being taken to a negative power, so leave it alone. Don't mess with it. Just like we didn't mess with the 3/4, no need to mess with the y to the 3rd. Make it into a fraction by putting it over 1 so that we can multiply across now. What do we have? 3 times 1 times y to the 3rd.
3.
3y to the 3rd. And downstairs we have 4 times x squared times 1. 4x squared. We look at it just one last time and say, can we do anything else? Do we need to do anything else? No. There's our answer. Okay, how about this next one? A to the -4 over b to the -2. How about we write it first as a division problem? Because whenever you have a negative power in that fraction downstairs, you're going to want to write it as a anytime you have a fraction like this, a fraction problem where everything is involved in the fraction, rewrite it as a division problem. Start there. Okay, now, before we do any multiplying by the reciprocal, remember, like we did in that one that I was kind of confusing you in, let's simplify them and leave it as a division problem first. Okay, so what is a to the -4? Do we need to simplify it?
Yes.
Yes. As what?
1 over
1 over
a to the 4th.
a to the 4th. Divided by, we're not switching anything yet,
1 over b to the 2nd.
1 over b to the 2nd. But now it is not multiplication, it is division, so we're going to change it to multiplication. So the first factor does not ever change, it stays what it is. The second factor becomes its reciprocal, so b to the 2nd over 1. Division to multiplication, what you're dividing by becomes its reciprocal. And now we multiply across the top. 1 times b squared, b squared. A to the 4th times 1, a to the 4th. There we go. Questions? I look at ones that have to the 0 power in them and I get excited because I know how easy they are. What's true about anything to the 0 power?
1.
It's 1. So I can say this is m to the -3 times 1 over 1. Can't I? Can I do that?
Yeah.
Is it that simple?
Yep.
Okay. No. Well, what's going to happen with these ones really? Because we have a multiplication.
Cancel each other out.
And, okay, so they kind of cancel each other out because there is multiplication here, not addition or subtraction, so we can do that. And now we're going to say, oh, I got m to the -3 left. I say I'm done.
1 over m to the 3rd.
Yeah, so to a negative power, I can't stop yet. I have to rename that as 1 over m to the +3 power. There we go. One last one. How do you think we're going to start this one? Writing it as a division problem. g to the negative 5 divided by 2h to the 4th. Does g to the negative 5 need to be simplified? Yes, what are we going to simplify it to? 1 over g to the 5th divided by, does 2h to the 4th need to be simplified?
Nope.
No. But since we've got a fraction now, let's make that one into a fraction. Because now we will change it to a, we will change the problem instead of being multiplied by the reciprocal. Does the first one change to its reciprocal? No, don't mess with that one. Times 1 over 2h to the what, Hayden? To the 4th power. Yeah, not h4. Now are we ready to multiply? Multiply
Yes.
across the top, we get
1.
1. Multiply across the bottom, we get 2 comes first.
H to the 4th.
Oh, does h come before g?
No,
What do we
it
say? E,
doesn't.
F, G,
2G to the 5th.
2g to the 5th, h to the 4th. Woohoo! There we go. We got this. This is what you will be doing in your homework today. Anybody have any of you want me to go back to